There is a moment, somewhere in the silent thrum of midnight, when the sky above seems to hold its breath. The world below, draped in the hush of sleep, is unaware. But out there, far beyond the reach of city lights, beyond the curl of our atmosphere, past the looping orbits of satellites, something stirs. It is not light that reaches us, not a comet's tail or the shimmer of a distant sun, but something stranger, invisible, intangible, yet undeniable. A whisper across the electromagnetic sea, a signal, and it is not alone. For years, the great radio dishes and vigilant spacecraft of Earth have caught these mysterious threads, bursts, patterns, pulses, emerging from the cosmic darkness, signals that, for all their strangeness, refuse to resolve into meaning. Are these the greetings of other minds, distant and unknowable? Or are they the wild symphonies of nature, playing to rules not yet written in our books? With every new detection, suspicion coils anew. What is NASA not telling us? What secrets drift between the stars waiting for us to listen? We find ourselves, as so often in the history of science, at the intersection of awe and uncertainty. The story of mysterious cosmic signals is not a single story, but a tapestry of wonder, confusion, hope, and sometimes fear. It begins, as all stories of discovery do, with a question. In the summer of 1967, a young astrophysicist named Jocelyn Bell, then a graduate student at Cambridge, sat hunched over rolls of chart paper. The radio telescope she helped build, a sprawling forest of wooden poles and wires, had been designed to study the flickering radio waves of quasars. Yet the signal she found was not a quasar. In the paper, the pulses appeared as ticks, impossibly regular, one every 1.337 seconds. It was so precise that she and her supervisor, Anthony Hewish, half-joked that it might be the handiwork of little green men. The world would come to know this discovery as the first pulsar, a neutron star spinning like a lighthouse at the edge of collapse. What began as a candidate for alien communication became a triumph of physics, rewriting our understanding of stellar death. But this is the scientist's paradox. For every mystery solved, a dozen new ones arise. The cosmos is a symphony of signals, and not all resolve into the familiar chords of gravity and nuclear fire. Sometimes, as in the case of the pulsar, the universe reveals itself as stranger than we imagined. Other times, it remains silent, withholding its secrets. As the decades rolled on, radio telescopes grew in power and ambition. The giant dish at Arecibo, now collapsed into a ruin of memory, scanned the heavens. The very large array in New Mexico, its arms stretching across the desert, listened. The Parkes Observatory in Australia, with its iconic white bowl, turned its ear to the southern sky. And then, in the late 1970s, something extraordinary happened. The Big Ear radio telescope at Ohio State University, a vast metallic ear pressed against the night, caught a signal. It was loud, narrowband, and utterly unexpected. For 72 seconds, the receiver filled with a burst so powerful that astronomer Jerry Amon, tasked with reviewing the data, circled it in red ink and scrawled a single word in the margin: "Wow." The wow signal, as it became known, fit no known natural source. It was not a pulsar, not a satellite, not the echo of an earthly transmitter. Its frequency, 14 to 20 megahertz, was the natural emission line of hydrogen, the universe's most fundamental element. If you were to design a cosmic calling card, this is the frequency you would use. Yet the wow signal was a whisper, not a conversation. It never repeated. All attempts to hear it again failed. No one could say whether it was an artifact, a prank, a misreading of cosmic static, or something more. It remains to this day an open wound in the annals of SETI, the search for extraterrestrial intelligence. But the search did not end. In the years since, astronomers have cataloged a menagerie of cosmic signals that resist easy explanation. Fast radio bursts, or FRBs, are among the most intriguing. First discovered in 2007 by Duncan Lorimer and his student David Narkovich, FRBs are fleeting, millisecond-long flashes of radio energy that seem to come from distant galaxies. Their power is immense. In those few milliseconds, some release as much energy as the sun emits in a day. They are so brief, so sudden, and so bright that they appear to violate common sense. Are they the collapsing hearts of massive stars, the flares of magnetars, those hypermagnetic neutron stars? Or as some whisper, are they the signatures of alien engineering? Perhaps the leakage from vast interstellar beacons, or the propulsion systems of light, sails the size of continents. The debate is not merely academic. In 2015, a team led by Harvard astrophysicists Avi Loeb and Manasvi Lingam published a provocative paper, Could Repeating FRBs Be Evidence of Advanced Civilizations Using Immense Energies to Push Spacecraft Between the Stars? The hypothesis is not so easily dismissed as wishful thinking. It is, instead, a reminder of how little we know about what is possible. There are other signals too. In 2011, researchers with the Kepler Space Telescope detected a star, KIC 8462852, now known as Tabby's star, whose light dimmed and flickered in ways never seen before. Some speculated about swarms of comets, others vast artificial structures, a so-called Dyson sphere, designed to harvest the energy of an entire sun. Further observations have favored natural explanations, but the allure of the unknown remains. Still, for every tantalizing signal, there are hundreds of false alarms. The history of SETI is littered with hopeful detections that collapsed under scrutiny. In 1997, a burst of radio energy detected by the Parkes Observatory sent shivers of excitement through the community, until, after exhaustive checks, it was traced to the opening of a microwave oven in the staff kitchen. The universe, it seems, delights in trickery. Yet, even as natural explanations are found, the signals themselves grow stranger. In April 2020, astronomers detected an FRB coming not from a distant galaxy, but from within our own Milky Way, a magnetar known as SGR 1935 Plus 2154. This was a clue, a thread to follow. Perhaps at least some FRBs are the death cries of magnetars, their surfaces torn by magnetic storms of unimaginable fury. But not all signals fit so neatly into the catalogs of known phenomena. In 2019, the Breakthrough Listen project, an ambitious SETI survey funded by billionaire Yuri Milner and advised by Stephen Hawking, announced the detection of a peculiar narrowband signal from Proxima Centauri, the nearest star to the Sun. The signal, called BLC1, was tantalizing. It appeared at a frequency rarely used by terrestrial transmitters, and it persisted for over 2 hours. Yet, as with so many before it, further investigation revealed the likely culprit: human-made radio interference, masquerading as a message from the stars. With each detection, with each disappointment, the line between the possible and the impossible shifts. The boundary between natural and artificial blurs. The universe is not obliged to be comprehensible. It is, as the physicist Richard Feynman once said, stranger than we can imagine. And yet, beneath the surface, suspicion festers. Why is it that the most promising signals so often vanish before they can be confirmed? Why does the official story, so neat and so final, never seem to satisfy? In the corridors of power, in the control rooms of NASA and the back offices of the National Security Agency, what is known and what is withheld? Are we, the public, hearing the whole story, or only what we are meant to hear? NASA, for its part, maintains a careful silence. Officially, the agency insists that all detected signals are subjected to rigorous analysis, and that any potential evidence of extraterrestrial intelligence would be shared with the world. The SETI protocols, drafted in the 1980s and since revised, require that any credible detection be confirmed by independent observers and reported to the United Nations. Yet history is replete with moments when information was withheld for the public good. The discovery of the first Soviet satellite, Sputnik, was not announced by the USSR until it had already circled the Earth. The detection of gamma-ray bursts in the 1960s, now known to be the deaths of distant stars, was initially classified by the US military for fear that they might be evidence of secret nuclear tests. In the world of intelligence and security, secrets are currency. The possibility of a message from another civilization is not merely a scientific curiosity, it is, potentially, a matter of global significance. What might it mean for religion, for politics, for the fragile equilibrium of nations if the existence of other minds were confirmed? Would we be told, or would the knowledge be held back, weighed and measured, released only when the world was judged ready? There are those who believe that the answer is already known. In the shadowy subculture of UFO researchers and disclosure activists, the conviction runs deep that NASA and other agencies have detected signals they cannot explain, and that these detections are being kept from the public. Whistleblowers have come forward, bearing tales of intercepted transmissions, of classified data, of hurried cover-ups. Most have been dismissed, their claims unsubstantiated, their reputations shredded by association with the fringe. Yet the questions remain. It is easy to scoff. The conspiracy theory is as old as secrecy itself. But in the annals of science, not every dismissed idea is wrong. Sometimes the truth is stranger than the most fevered imaginings. To understand the full scope of the mystery, we must delve deeper. What precisely are these signals? How are they detected? And how are they analyzed? What distinguishes a natural phenomenon from the artifact of intelligence? What, in short, would a message from another civilization look like? And would we recognize it if we saw it? The search for extraterrestrial signals is an exercise in humility and imagination. The electromagnetic spectrum is vast, from the long, lazy waves of radio to the searing energies of gamma rays. Each frequency band carries its own possibilities and its own hazards. The Earth is awash in artificial noise, television broadcasts, radar pulses, cell phone chatter. To find a whisper from the stars, we must first filter out the clamor of our own making. At the heart of the search are radio telescopes, immense, precise, and sensitive. The Arecibo dish, before its collapse in 2020, was the world's largest single-aperture telescope, able to hear the faintest murmurs from across the galaxy. The Green Bank Telescope in West Virginia, an engineering marvel, can pinpoint the direction of a signal to within a fraction of a degree. The Allen Telescope Array in California, funded in part by Microsoft co-founder Paul Allen, was designed specifically for SETI, able to scan multiple stars simultaneously. Detection is only the beginning. The real work is in the analysis. Astronomers look for signals that are narrowband, confined to a single frequency. Unlike the broad, noisy emissions of natural sources, they seek regularity, repeating patterns, modulated pulses, sequences that suggest purpose rather than chaos. They compare the arrival times at different telescopes, searching for parallax, the telltale shift that betrays a signal's origin. And yet, the challenge is immense. The universe is full of surprises. Pulsars, once candidates for alien beacons, are now cataloged by the thousands. Quasars, the blazing hearts of distant galaxies, were once thought impossible. Magnetars, with their titanic magnetic fields, release energies that defy intuition. The process is, in the end, one of exclusion. Each candidate signal is subjected to a battery of tests. Is it moving with the stars or fixed to the Earth? Does it repeat? Does it coincide with known satellites or terrestrial transmitters? Is it seen by other telescopes, in other places, at other times? Only when every earthly explanation is exhausted does the possibility of the extraordinary arise. And even then, certainty is elusive. The WOW signal, after more than 4 decades, remains unexplained. It has never been repeated, never confirmed. It is a ghost, a riddle, a single note in an endless cosmic symphony. The search is not limited to radio. Optical SETI, a newer discipline, scans the heavens for brief flashes of laser light, signals that would, in theory, outshine a star for a fraction of a second. The Harvard-Smithsonian Center for Astrophysics operates a dedicated optical SETI telescope, targeting nearby stars in the hope of catching a deliberate flash. The rationale is simple. If we can transmit data using lasers, so might others. But here too, the limits of technology impose caution. The sky is vast, and our instruments are finite. The odds of being aimed at just the right moment, by an alien transmitter, are vanishingly small. The search is, as Frank Drake once observed, like listening for a phone call on a single randomly chosen frequency, at a single instant, on a planet of billions. Still, technology advances. The Square Kilometre Array, now under construction in Australia and South Africa, will be the largest radio telescope ever built, able to survey the sky with unprecedented speed and sensitivity. The Breakthrough Listen initiative, with access to the world's most powerful instruments, is conducting the most comprehensive search in history, scanning millions of stars across billions of frequencies. And as the search expands, so does the mystery. Fast radio bursts, once thought rare, are now detected almost weekly. Some repeat, others do not. Their origins are scattered across the sky, in distant galaxies, and once, in our own. The mechanisms proposed are as varied as the signals themselves: the collapse of neutron stars, the merger of black holes, the flares of magnetars, the echoes of cosmic strings, hypothetical defects in the fabric of space-time itself. Into this maelstrom of data and uncertainty, the question of intent looms large. What would an artificial signal look like? How would we know? The SETI community has long debated this. The so-called water hole, the quiet region of the radio spectrum between the emission lines of hydrogen, 1420 MHz, and hydroxyl, 1665 MHz, has been favored as a likely band for interstellar communication. It is quiet, natural, and universal, a place where any civilization with radio technology might listen. The logic is compelling, but it is also anthropocentric. It presumes that alien minds think as we do, that they share our logic, our physics, our priorities. The philosopher and scientist Frank Drake, in his famous equation, tried to quantify the odds. How many civilizations exist? How many are transmitting? For how long? The equation is a litany of uncertainties. We know only the first term, the rate of star formation. All the rest, planet formation, the emergence of life, the rise of intelligence, the will to communicate, are estimates, guesses, hopes. And yet, the search continues. In the laboratories of NASA's Jet Propulsion Laboratory, in the data centers of Breakthrough Listen, in the lonely control rooms of radio telescopes scattered across the globe, the work goes on. Every night, signals are captured, cataloged, analyzed. Most are dismissed. Satellites, aircraft, cosmic noise. A few linger, haunting the databases, awaiting further scrutiny. Is it possible that something has been found, something so extraordinary that it cannot be revealed? The question is not idle. In 2011, the Kepler Space Telescope detected a star whose light dimmed in ways that defied explanation. Tabby's star, as it became known, was the subject of fevered speculation. Was it surrounded by a swarm of comets? Or by the debris of a shattered planet? Or just possibly by a megastructure built by an advanced civilization, the so-called Dyson sphere? The debate was fierce. Data was pored over, models constructed, arguments waged in the halls of conferences and in the pages of journals. In the end, the weight of evidence favored a natural explanation: dust, perhaps, or swarms of comets. But the possibility, once raised, could not be unraised. The searchers had glimpsed the edge of the possible. And what of NASA? The agency is, in many ways, the public face of space exploration. Its missions, Voyager, Pioneer, Cassini, New Horizons, have carried our machines to the edge of the solar system and beyond. Its telescopes, Hubble, Spitzer, Chandra, have opened new windows on the cosmos. Its scientists are among the foremost experts in the world. Yet NASA is also an agency of the United States government, bound by rules of secrecy and security. Its data is, for the most part, open, its discoveries published, but not all. In the aftermath of the Cold War, the agency's ties to military intelligence run deep. The National Reconnaissance Office, the National Security Agency, the Defense Advanced Research Projects Agency. These are the silent partners in the dance of discovery and secrecy. There are, within NASA, protocols for the detection of extraterrestrial intelligence. The SETI protocols, drafted in the 1980s, require that any credible signal be confirmed by independent observers and that the discovery be reported to the United Nations. But the protocols also allow for delay, for consultation, for the weighing of consequences. What, after all, would be the impact of such a discovery? Would it unite humanity or divide it? Would it inspire awe or fear? Would it be used for good or for ill? In the shadowy corridors of power, such questions are not theoretical. There have been leaks, of course. In 1996, NASA's announcement of possible fossilized bacteria in a Martian meteorite, ALH 84001, set off a firestorm of debate. The evidence was ambiguous, the interpretation controversial. Yet the announcement was made, and the world responded. In the decades since, the search for life has moved to the forefront of NASA's agenda. The Mars rovers, the Europa Clipper, the search for biosignatures in the atmospheres of distant exoplanets. Still, the question remains, would we be told? Or would the truth, if it came, be too dangerous, too destabilizing to share? In this, the story of mysterious cosmic signals is not merely a scientific puzzle, but a mirror held up to our own hopes and fears. The search for alien messages is, at its core, the search for companionship in the void. It is the hope that we are not alone, that our questions echo across the dark, that there is someone, somewhere, listening. But it is also a test of our willingness to face the unknown, to accept the possibility that the universe is not ours alone. In the words of Arthur C. Clarke, two possibilities exist. Either we are alone in the universe, or we are not. Both are equally terrifying. The signals for now remain unexplained. Some may be the flares of dying stars, the crackle of magnetic storms, the echoes of cosmic events too vast for our minds to grasp. Others may be the artifacts of our own technology, ricocheting through the void, mistaken for messages from afar. But a few, a precious few, resist all explanation. They are the outliers, the anomalies, the ghosts in the machine. They haunt the databases, the memories of astronomers, the dreams of those who look up at the night sky and wonder. In the end, the mystery is not in the signals themselves, but in our response to them. The search for meaning is a human endeavor, as ancient as the stars. We listen, and we wait. The universe, indifferent, goes on. Yet the story does not end here. The signals, strange and beautiful and maddening, continue to reach us. Each is a message, if not from another mind, then from the cosmos itself, a reminder of how much we do not know and how much there is yet to discover. Imagine for a moment the distant future. Humanity, spread out among the stars, has become the signal, the transmitter, the sender of messages into the void. What will we say? What will we hope to hear in return? For now, we are the listeners. The great dishes turn, the data streams in, the signals are sifted and weighed. Somewhere in the static there may be a message, waiting for us to understand. The sky is vast, and the night is long. The search goes on. Beneath the sweep of cosmic silence, beneath the cold certainty of the numbers, there is a heartbeat, a longing for contact, for recognition, for meaning. The signals, whatever their origin, are a mirror for our own desires. They reflect not only the unknown, but the unknowable. In that reflection, we see ourselves, curious, fragile, hopeful, and alone. Or perhaps not alone. Perhaps even now another mind waits, listening, wondering. The mystery endures. The signals, cryptic and unresolved, are the questions we ask of the universe, and the answers we hope to receive. In the quiet halls of observatories, in the flicker of computer screens, in the dreams of those who dare to wonder, the search continues. The signals are out there, waiting, and so are we.